Learning target 36 is all about calculating power, which is the rate at which work is done. So we write that out as W over delta T. With some of these problems, they might not give us the amount of work done. They might give us, say, a force and a displacement. But we know already that work is equal to the displacement vector times the force vector times the cosine of the angle between those two. So we can solve for W if needed. The other thing this does for us is, since work over time is equal to power, I can also say that power is equal to the displacement divided by the time times force times cosine theta. And displacement over time, that's just velocity. Velocity times force times the cosine of the angle between them. So that's where we get this form of the equation. So that's where our example problem is going to be, the equation that we'll use for the example problem. In this one, we've got a box that's moving across a surface with friction at a constant speed, and we have some applied force causing that to happen. And the question is, what's the power generated by, or the power that's required, rather, to move this box across the surface? So we see that power is going to be equal to force times the velocity times the cosine of the angle between them. Velocity is to the right, and that force is to the right, so the angle is just going to be 0. Velocity is given, so the only work we have to do here is figure out what that force would be to make this travel at a constant velocity. So for that, we'll just do a quick free body diagram. We know that all our forces have to add up to 0. So we'll have normal force going up, and weight, or mass times gravity, down. We've got the applied force to the right, and we've got friction to the left. And friction, remember, we can do mu times the normal force to get that. So we can see from this then, if we're traveling at a constant velocity, that our applied force and frictional force have to be equal to each other, and that the normal force and the weight force have to be equal to each other. So start in the y direction. Net force in the y is equal to mass times acceleration in the y, so that's normal minus mg is to equal 0. So the normal force is equal to mass times gravity, which is going to be equal to 98 newtons. And in the x direction, we'll have net force in the x direction equals mass times acceleration. So that would be the applied force minus the force of friction. And that would be equal to 0. So the applied force has to equal the force of friction, which is equal to mu times the normal force, which is 0.3 times 98 newtons. And so our applied force and frictional force both have a value of 0.3 times 98, which is 29.4 newtons.
Katie Wong, please come to the office. Katie Wong.
All right, and then we have everything we need to solve this one. So our power is going to be equal to force times velocity times cosine of the angle, where force is 29.4 newtons. Velocity was that given 4.5 meters per second times the cosine of 0, which is just 1. So 29.4 times 4.5 then is going to be 132, and the units on power are joules per second, or more commonly we write that as watts.